Morning, my dear students. In the previous video clip, there is a very important that is equation, that is Einstein photoelectric equation. It is a very important equation. That equation is incident photon energy is equal to, that is the work function, sum of the work function, and that is the kinetic energy of the, that is the photoelectrons. Now incident photon energy, that is h nu. Now this is h nu naught, and plus that is said to be 1 by 2 mu square. What is this one? The frequency of the incident light. What is totally incident photon energy? What is this one? Threshold frequency of the photosensitive material. What is this one? Planck constant. Totally it is work function. This is the kinetic energy of the photoelectrons. After the emission of the photoelectrons, it is moved with a certain velocity and also with a certain kinetic energy. Now this is about Einstein explanation, and we will discuss the different cases. If the incident frequency of light is greater than threshold frequency, what happens? If the incident frequency of light is equal to threshold frequency, it is what happens. If the incident photon energy is less than the threshold frequency, what happens? All these things I have discussed already in a previous video clip. Now you come to the point that is a very important particle nature of the light. And in the wave optics, you discuss about the different phenomenon. There is the interference of light, diffraction of light, and the polarization of light. And one more important phenomenon, reflection of light and refraction of light. In all the cases, now the light behave as a wave. That is in the wave optics. Light behave as a wave. Light behave as a wave. In this wave nature of light, we explain the reflection, refraction, interference of light, and diffraction of light, and polarization of light, but not rectilinear propagation of light. Okay, now this is said to the wave nature of light. Light is behave as a wave. Now, the quantum theory of radiation is proposed by Planck's, W.C. Planck's in 1900. Okay. And then the energy is absorbed or emitted. It is not a continuous, it is in the discrete packets of energy. These packets of energies are called quantum. Each packet of energy is called quantum. And then each packet of energy is equal to h nu. Now Einstein explained the photoelectric effect based on quantum theory of radiation. Now he applied this quantum theory of light to the light. The name of the quantum theory of radiation. Light apply. The light is absorbed or emitted. It is not a continuous. It is in the discrete packets of energy. These packets of energies are called photons. Photons in the name ಕೊಟ್ಟ ವ್ಯಕ್ತಿನ ಯಾರು? Einstein. ಅವಾಗಲ್ಲೇ ಅದು photon is a particle. This is a particle. Now that photon is incident and a photosensitive material, then it is interact with the material, then the photoelectrons are emitted. If the incident photon energy is greater than the threshold, greater than the work function, at that time definitely the photoelectrons are emitted. Now here in this photoelectric effect, the light is considered as a particles. It means photons. That is said to be photons. That means particle nature. That is said to be particle nature. Now see here, during the explanation of the reflection, refraction, interference, diffraction, and polarization, light behaves as a wave. When you explain the photoelectric effect, at that time, light behaves as a particle. Therefore, this is said to be dual nature of light. Dual nature of light. ಇದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? Dual nature of light ಅಂತ ಹೇಳ್ತೀವಿ. Dual nature of light concept. Dual nature of matter ಬೇರೆ. ಅದು ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. Dual nature of matter ಬೇರೆ, dual nature of light ಬೇರೆ. What is the meaning of dual nature of light? Light sometimes behave like a wave. Behave as a wave. The light sometimes behave like a particle. During interference, diffraction, polarization, you explain these phenomena. Light behave as a wave. During explanation of the Compton effect and photoelectric effect, light behave as a particle. This is said to be dual nature of light. Now, dual nature of light. Now come to the particle nature of light. At that time, particle of the nature of the light, in this case, that particle is said to be photon. Each photon energy E is equal to h nu. Then C is equal to nu into lambda. During the interaction of the matter, the light is incident on the photosensitive material and then it is interact. At that moment, that it is behave like a particle. That energy is also is equal to h lambda divided by C. Nu is the frequency, h is the Planck constant, E is the energy. What about lambda? Lambda is the wavelength of the light, or you said to be photon. Then C is the velocity of the light, or you said to be velocity of the photon. Now you come to this according to that is the Einstein explanation. That energy is equal to mc square. Mc square is equal to h nu. At that mc is equal to, take the c this side, h nu by c. Now this is in the form of mv. It means you say to be photon. The momentum of the photon is equal to h nu by c. Momentum of the photon is h nu divided by c. This is the momentum of the photon. Then you come to the point that is said to be properties of the photon. What are the characteristics of the photon? What is the properties of the photon? Now, first property, the photon is that is interact with material. At that time, it is a particle nature. That particle is said to be photon. This is the first property. Second property is energy of the photon is equal to h nu, or it is said to be hc by lambda. That is the second one. Then momentum of the photon, h nu by c. You got the expression of here, h nu by c. Now, energy of the photon is directly depending upon that frequency. When frequency increases, energy of the photon is increases, but is independent of the intensity. Already in the previous video clip, that is during the explanation of the experimental setup of the photoelectric effect, at that time, what is the meaning of intensity? It is the number of photons incident per second is called intensity. Now, energy of the photon, it is depends on frequency but independent of intensity. Now, there is no charge. There is no charge of the photon. Photon ಗೆ charge ಇರಲ್ಲ. ನಾವು ಪ್ರೋಟಾನ್ ಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂತೀವಿ, ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರ್ತದೆ ಅಂತ ಹೇಳ್ತೀವಿ. ನ್ಯೂಟ್ರಾನ್ ಎಲೆಕ್ಟ್ರಿಕಲಿ ನ್ಯೂಟ್ರಲ್ ಅಂತೀವಿ. ಇದಕ್ಕೆ ನಾವು ನೋ ಚಾರ್ಜ್, ಮೀನ್ಸ್ ನ್ಯೂಟ್ರಲ್, ನೋ ಚಾರ್ಜ್. Therefore, it is unaffected by the electric field and magnetic field. ಅಂದ್ರೆ ನಾವು ಅಕಸ್ಮಾತ್ ಈ ಫೋಟಾನ್ ಹೀಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಎಂಟ್ರಿ ಆದ್ರೂ ಅದಕ್ಕೆ ಏನೂ ತೊಂದರೆ ಇರೋದಿಲ್ಲ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈಗ ಎಂಟ್ರಿ ಆದ್ರೂ ತೊಂದರೆ ಇಲ್ಲ. ಇವನ್ ಗ್ರಾವಿಟಿ ಕೂಡ ಏನಾಗಲ್ಲ ಹೇಳ್ರಿ, ಇದಕ್ಕೆ ಎಫೆಕ್ಟ್ ಆಗಿದೆ. ಯಾಕಂದ್ರೆ ಇಟ್ಸ್ ಮಾಸ್ ಆಫ್ ದ ಫೋಟಾನ್ ಇಸ್ ವೆರಿ ವೆರಿ ಲೆಸ್, ಆಲ್ಮೋಸ್ಟ್ ದಟ್ ಇಸ್ ನೆಗ್ಲಿಜಿಬಲ್. ಇಟ್ ಇಸ್ ಕನ್ಸಿಡರ್ ಎಸ್ ಎ ಜೀರೋ ಅನ್ನಬಾರ್ದು, ಬಟ್ ಹೌ ಟು ಸಿಂಪ್ಲಿ ಪ್ರಾಕ್ಟಿಕಲಿ ಸೇ ದಿಟ್ ಇಸ್ mass of the photon is zero. It is also unaffected by what you say gravity. Now, sixth property. This is the material particle, or you say to be atom. This photon is incident and it is collide to this one. Once you collide this one, now collide to this one, the energy and momentum, it is conserved. It is a conserved, but number of photons may be conserved or may not be conserved. ಅಂದ್ರೆ ಕೊಲೈಡ್ ಆಯ್ತಾ, ಈ ಫೋಟಾನ್ ಹೀಗೆ ಹೋಗುತ್ತಾ, ಮತ್ತೊಂದು ಮಟೀರಿಯಲ್ ಪಾರ್ಟಿಕಲ್ ಹೀಗೆ ಹೋಗುತ್ತಂತ, ಒಂದು ಫೋಟಾನ್ ಇನ್ಸಿಡೆಂಟ್ ಅಂತ, ಒಂದು ಫೋಟಾನ್ ಹೊರಗೆ ಬಂತಂತ, ಇದು ಕಾನ್ಸರ್ವ್ಡ್. ಕೆಲವೊಂದು ಟೈಮ್ನಾಗ ಏನಂತ, ಈ ಫೋಟಾನ್ ಬಂದಿದ್ದು ಈ ಇದ್ರ ಜೊತೆ ಕೊಲೈಡ್ ಆದ ತಕ್ಷಣ ಇದು ಅಬ್ಸಾರ್ವ್ ಆಗಿದ್ದು ಫೋಟಾನ್ ಸ್ಕ್ಯಾಟರ್ಡ್ ಆಗಿ ಬರ್ಲಿಕ್ಕಿಲ್ಲ, ಕೊಲೈಡ್ ಆಗಿ ಬರ್ಲಿಕ್ಕಿಲ್ಲ. ಸಪೋಸ್ ಫೋಟಾನ್ ಇನ್ಸಿಡೆಂಟ್ ಆಗುತ್ತಾ, ಅದು ಅಬ್ಸಾರ್ವ್ ಮಾಡ್ತಾ ಮತ್ತೊಂದೆರಡು ಫೋಟಾನ್ ರಿಲೀಸ್ ಆಯ್ತು, ಇನ್ಸಿಡೆಂಟ್ ಫೋಟಾನ್ ಒಂದು, ಹೊರಗಡೆ ಬಂದಿದ್ದು 2 ಫೋಟಾನ್ಸ್. ಅದಕ್ಕೆ ಫೋಟಾನ್ಸ್ ಕೆಲವೊಂದು ಟೈಮ್ನಾಗ ಕಾನ್ಸರ್ವ್ ಆಗುತ್ತಾ, ಕೆಲವೊಂದು ಟೈಮ್ನಾಗ ಕಾನ್ಸರ್ವ್ ಆಗುತ್ತಿಲ್ಲ. ಅದಕ್ಕೆ when a photon collide with a particle or you say the atom, the energy is conserved, the momentum is conserved, but number of photons may be conserved, may not be conserved. Now all photons are propagated at the same velocity, that velocity is equal to velocity of light, that is 3 into 10 to the power of 8 meter per second. So velocity of the photon. Then finally, the final property, that is the rest mass of the photon is equal to 0. This is unbarred. Photon, if it is the photon is rest, it does not exist here. That is the energy packet. That is once it is that is said to be rest, it means that energy is disappear. The meaning of this one is disappear. This is about the properties of the photons and the interaction of the material, and discuss the dual nature of matter in the next video clip. Thank you.